children, today we are going to do something very interesting. You are aware of 4-digit numbers. Now we are going to meet 5-digit numbers today. So which is the smallest 5-digit number? Smallest 5-digit number is 10,000. And we have our abacus here. Do you notice? Ones, tens, 100, 1000, 10,000. So if I want to represent 10,000, this is 10,000 on abacus. Easy, isn't it? Let us try representing this number on abacus. Let us first read this number. What is it? It is 10,000, 3,000, 500, 60 and 4. So how does it read? It reads 13,564. So that means it has 4 ones, 6 tens, 5 hundreds, 3 thousands and 1 10,000. So 4 ones. 4 ones means 6 tens. 5 hundreds. 3 thousands. 1 tenth, which was already there. So this makes it 13,564. So easy, wasn't it? You can represent any of the numbers on abacus like this and see its placement, convert it into expanded form and read the number. Now let me ask you something very interesting. Supposing I have these 4 numbers with me, 1, 0, 5 and 3. Can you create some 5-digit numbers using this? Let us create together. I can have a number where I use 0 twice. I can have a number like this. I can even create a number with 3 twice. I can have a number like this. So the list is endless. I can create so many numbers out of it. Supposing we create a few more. And let us say one we have this. So in these numbers, can you tell me which is the largest and which is the smallest? How do we do that? When we want to find out the largest or the smallest, where do we start our comparison from? We will start our comparison from here. So we will first compare the 10,000 position. So when I am comparing the 10,000 position, I can very clearly see that 5 is largest. So this number becomes largest. And now, which is the smallest number? Again, if I say I will compare from the 10,000 position, what happens? I have this number, this number, this number and this number all at 1. So I cannot compare them. So I go to the next position, that is the 1000 position. Now in 1000 position, it is very clear that this is 0 and rest of them have 3. So this becomes my smallest number. Easy, isn't it? Now supposing I tell you, let us play this little more and we try to arrange them in an order. So if we are arranging them in an order, what will happen? If I say I am arranging, I give number 1 to this position. So which number will take second position? Out of this, again we will compare the 10,000 positions. So this will take the second position. Now which number will take third position? Now this is the smallest number. This will come at end. We will take these 3 numbers into consideration. Their 10,000 position is same. Their 1000 position is same. So now we compare their 100 position. In 100 position, this has 5, this has 3 and this has 0. So it is very clear this will be the third position. This will be the fourth position. This will be the fifth position and this takes the sixth position. Interesting, isn't it? Now let us move little further and we try to create our own numbers. I have these 18 beads here. Let me first remove these beads from here. Just as using these 4, I created these numbers. Now using these 18 beads, I am going to create number on my abacus, but with this restriction that on each one of my rod, that is at each position, at each place value, we will have different number. So let us start. So I am going to place first one bead in each. So what is my target? I want to create a number in which all these will take different numbers. So I have placed one in each. Now supposing I place 2 in this, 2 in this and 2 in this. I am not placing any here. Why? Because I am fixing its position as 1 and now I will fix its position as 2. So I will see if I can still manage. Supposing I decide I fix its position as 3, so I place 4 here. So I can place 5, 6, 7, 8, 9 here. So I have created a number 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 and 8 here. So I have 8 beads here, 4 beads here, 3 beads here, 2 beads here and 1 bead here. Is the number all right? Is the total coming out to be 18? Can you check out for me? Yes, it is coming out to be 18. So I have created this number using these 18 beads. I have got this number as 8, 4, 3, 2, 1. Now this with these numbers, this forms the largest number. And what will be the smallest number if I'm supposed to use these digits only, that is 8, 4, 3, 2 and 1? Yes, the smallest number which will be created will be 1, 2, 3, 4 and 8. That is, this number was 84,321 and what have I created? 12,348. So let us create 12,348 here. So I have 12,000. My 12,000 is ready. Then I want 340 and 8 here. Now let us move to the next thing. We are going to do something even more interesting than what we have done till now. We are going to round off this number, and that too using abacus. So first let us create this number on our abacus. It is 12,746. So let us remove these beads. We will use the beads we were using earlier. So we have 6 ones. Four tens. Seven hundreds. Two thousands. And one 10,000. Now first I am going to do rounding off at tens. So rounding off at tens means what? That this is the position I am going to round off the number. So whichever is the position, if we are rounding it off at 10, we will look at the number on its left side. So what do I have on its left side? I have these 6 beads. And what is the rule of rounding off? That if the number on the left is 5 or more, the rounding position takes one more number and this becomes 0. So that means as these are 6, I remove these 6 and I place one more digit here. So if I am rounding off at 10, the number becomes 12,750. Is that clear? Now let us do rounding at hundreds. Now our original number was 12,746. Let us first create back 12,746. Now I want to round it off at hundreds position. Hundreds position means this position. So I will look at the number on its left. What is on its left? Tens position. And what is the placement in tens position? It is 4 tens. 4 tens means number is less than 5. If number is less than 5, the place where we are rounding off remains the same and all the numbers on its left side become 0. That means we remove all these 6 beads. We remove these 4 beads also. And so what is our number now? It is that right? It is 12,700. So is this helping you to understand rounding off better? Now let us be little more adventurous and let us round at thousands. So first what do we have to do? We will create our number back. So this position and this position is intact. I have to place back 4 tens. and I have to place back 6 ones. Now what is my placement? I am rounding off at thousands. So this is my thousands place, and I have to look at which number. I will be looking at this number. Now look at the thousands place. This is the thousands place. We look at the position just left to it, that is hundreds position. Now how many beads do I have in hundreds position? I have 7 beads in hundreds position. And what is the rule? That if the number on the left is 5 or more, we add 1 to the position we are rounding off. So I will add one more bead here, and we round off to get 13,000. So I hope children you enjoyed this class and you got your concepts clear.